machine has to produce. Only when the machine is producing can you make money. Hi, I'm Johannes. I've been working at Zimmermann for 5 years as a development engineer, and I handle everything that can be implemented in a machine in terms of technical development or innovation. My daily work is very diverse. Digital application development is a kind of umbrella term that was defined for my job. I studied aerospace engineering, and even though at first glance this doesn't seem to have much to do with aerospace engineering, on second glance it actually has even more to do with it. Condition monitoring is a topic that is frequently mentioned when it comes to the development of large and complex data systems. So, I collect a lot of different data, and at first all this data is relatively useless, because if I have a lot of data but no idea what I want to do with it, I generate a lot of entropy but make little progress, meaning that the machine will eventually need to be repaired or some parts will have to be replaced. You can do all of this by combining many sensors and deriving a big answer from them. I have 50 different sensors that I interpret in various ways, and in the end, there is a single answer that comes out, telling me that something is currently wrong and to check this or that other component. We want a machine that produces a lot and requires little maintenance. That's a good machine. That's a mark of quality. And if we want to keep the production rate high, in other words, we want to use as much of the available time with the machine as possible. We want to maximize that, and we can maximize it if we can already tell in advance that certain components are developing faults. A machine that has faults. Not only does it produce for a shorter time, but it also produces with lower quality. If the spindle is no longer running true, then the spindle wobbles. If the spindle wobbles, then it no longer produces good parts. Maybe I've made a lot of chips, but in the end, all I have is scrap. And if I can tell the customer in advance, wait a minute, something on your machine isn't working the way it should, then I can possibly let them know before a lot of scrap ends up in the container and say, let's take countermeasures instead. And in that case, both the customer and we as the manufacturer can benefit, because the customer can see, okay, what actions or what am I doing with my machine that causes it to regularly get damaged. And we can see, okay, this component or this process is always responsible for this or that part breaking. Statistics already help us a great deal. A certain basic understanding of statistics and the integration of an AI application. If you bring those together, you can build good AI applications. If you just say, now I have AI and I'll let the AI work its magic, then you end up with a lot of nonsense and sometimes even bigger problems than solutions. That means if we think in advance about what the AI should be able to recognize, then we can build excellent AI solutions in the context of mechanical engineering. I like my job because my job is always a special challenge. I don't have anything that I just have to work through mechanically, beyond precision at F. Zimmermann means that we don't just see any kind of accuracy, but rather what ultimately makes a good machine.